Now we talk about the Greek rho. So the Greek rho measures the sensitivity of the option price to the interest rate. So basically it is change in price over change in interest rate. So if the interest rate changes by 1%, rho tells us by how much percentage the price of the call option or the put option will change. So for the call option, it is given as delta C by delta R. This is the formula. K is the strike, tau is the time to expiration date or maturity, exponential of minus R tau ND2. R is again the risk-free rate. And for put options, it is minus KT, exponential of minus R tau N minus G2. So basically just copy the above formula down. Notice there is a negative sign here and then there is a negative sign here. So let us do an example. So say the underlying price of the spot for the stock, commodity or financial instrument is $45. Volatility is 20%. Strike rate is 50. Risk-free rate is 0.05%. Tau is 3 months. Then the call option rho would be 1.681 and put option rho would be minus 10.783. So if we keep changing the strike price, you can construct an option ladder like this. So you keep everything constant and you just change the strike price. Then you get different rows for call and put. So basically, for example, this 1.681 says is that if the interest rate say increases by 1%, then the call option price would also increase by 1%. Whereas the put option price will go down by minus 10%. So that is the interpretation. Now rho is of very limited use because it measures sensitivity with respect to risk-free interest rate, and risk-free interest rate is not in the hands of a trader, it is in the hands of the government. So this will make sense only when the interest rates get changed. If the interest rates are not changing, then rho does not make any sense. So every time government announces a new interest rate or say a new rate of interest on treasury bills, then immediately the banks will start calculating the rho of their portfolio. But otherwise it is not used on day-to-day basis.